Welcome back, structural geology fans. Today is a big day as we hit on one of the most important skills for a field geologist, the ability to take measurements on structures and put these measurements on a map that lets other geologists know exactly what you saw out there. To begin, layers of rock are basically planes of rock, and faults and joints are basically planar breaks in rock. And even with a fold, we can imagine a plane of symmetry, and thus measuring planar features is key to our science. A place on a plane can be described in just two intersecting lines, but we go a bit farther to not only say where we are on the map, for which you can go back to the beginning of this series to review latitude and longitude or the USPLS system to get your location. But today we are going to learn how to represent the orientation of any plane in 3D space at your location on the map. To do this, we use the concepts of strike and dip. A strike is defined as the direction of the line made by an intersection of an imaginary horizontal plane with the plane of the structure in question. To simplify this discussion, let's focus on a layer of rock which has been taken out of its original horizontality and tilted in some direction. If we were to submerge our tilted layer in water, we would see the horizontal water surface intersecting the dipping layer in a line. We use our compass to measure and report the direction of that line. And at the Colorado School of Mines, we teach our students to prefer use of the azimuth system. This is the system that goes from 0 to 360 degrees around the compass rose. North is 0 degrees. East is 90, south is 180, west is 270 degrees. But wait, there is a problem here. Looking at our water intersecting our rock layer, we see that the strike line is just that, a line, not a directional arrow. So in this case, with the strike line going exactly north-south, we could call it 0 degrees for north or 180 degrees for south. Again, at the Colorado School of Mines, we teach our students a consistent method, and honestly, all geologists should start following suit for consistency and ease. We use what is known as the right-hand rule. First, you need to figure out which is your right hand. Then, put the fingers together and the thumb out at a right angle to the fingers. Now think that your fingers are heavy and want to go down the slope you are measuring. With the fingers of your right hand going down the slope of the plane of interest, your thumb will point in the one direction out of the two possible to use for the strike. So with our example with a strike line that is going north-south, we see that a right-hand rule would tell us to measure the direction to the south. In other words, we put the strike here as 180 degrees, not 0. Besides this strike azimuth number using the right-hand rule, we need to measure one other geometric aspect of the bed, its dip. The dip of a planar feature is the maximum angle between the plane and our imaginary horizontal surface. I have to say the maximum angle of dip, as any angle measured that is not perpendicular to the strike, will be less than the true dip of the bed. One way to quickly assess this dip direction is to actually, or imagine, pouring water on the planar surface and seeing or imagining which way the water would run. That is basically the dip direction, as water will tend to take the steepest angle down the face. For our previous example, the strike was 180 degrees and the dip is 45 degrees. In our notebook, we can quickly write down our location and 180/45. With that, we have the orientation of the plane in question. Note that I could say that the bed is dipping 45 degrees to the west, but I don't need to, as long as I use the right-hand rule. To repeat, we use the fingers of the right hand to point down dip, and our right thumb, at a right angle to the fingers, points us in the correct strike direction. Put your right thumb pointing in the direction of strike, and your fingers will be at a right angle in the direction of dip. So with a 180/45, we know the bed is dipping 45 degrees from vertical to the west. If the strike and dip were 0/45, that plane would be dipping 45 degrees to the east. Now that we have the concept of strike and dip using azimuth coordinates and the right-hand rule,